This is my lathe mill setup. What I have is the additional add-on milling head that goes onto the lathe 4000 series, and I'll demonstrate that later in other videos. But it's been a very useful tool for learning how to do basic milling with. I also purchased the rotary table, which is a necessity for a lot of things. I highly recommend someone who's starting out go right ahead and purchase the rotary table. I'll get into some of the, well, of course we have our shop mascot here. She's being shy at the moment, but she's very efficient at turning birdseed into poop. She keeps me company, someone to talk to. She's going to be shy right now and not talk for us, but she is very vocal about her concerns and opinions, trust me. This here is my homemade power feed for my Sherline lathe. I believe the lathe is a 4000 or 4500 series, but on the stock here the label says it's a 5500, which I believe is a mill head, so obviously this is a lathe that's been put together from many parts. The tailstock is brand new. I put that on there. The older tailstock, which is this one here, is the older style, which does not have the brass gibs underneath it. And I guess they had problems with repeatability on the older style, and that's why they upgraded to the new style, which does have the brass gibs. I don't know if you can see that, as seen right there. I believe that dates this lathe around the late 80s, early 90s. But it has been well taken care of. I bought it used. I replaced the gibs. I replaced the lead screws on it. The other replacement I did was the table. You can see the older style tables are a couple inches shorter, which really limits what you can do with the lathe. So that was another necessary upgrade that I did for it. But my favorite upgrade is my power feed. What this is a DC motor that I took out of an old copier machine. I believe it was the belt drive for one of the paper feeds. All I did was I turned two pieces of aluminum, made a belt sprocket out of it, did the same back here, cut a slot so that it fits into the pin that is on the end of that shaft. I took an old hobby power supply. This one here is a 14 volt power supply. I think it's about an amp or an amp and a half. I could be wrong on that. I did have to rewire it so that it has a switch on it. And what that switch allows me to do is to move the motor in either direction, forward or backward. I'll show you how that works real quick. You can see here, as far as I know, it's a good cutting speed. I've had real good results with it. And the nice thing about this one is that it is reversible. I know the Sherline lathe is not, or the Sherline power feed is not reversible. This one here with the switch on it, I can go in either direction, as you can see there. The downside to this is that it's not variable speed. I did put a potentiometer on it, a rheostat style potentiometer, but it turned out to be more trouble than it was worth, and it actually shorted out once because I didn't have it properly enclosed, and of course you get metal shavings that get into all of your equipment, so that's something you really got to be aware of. As far as having limit switches or table stops, at first when I mounted this, I had a gearbox, so it was a direct attachment from here to the shaft. And what would happen is it'd get to the end of the table here. If I didn't turn off in time, it would literally grind the gears. So I solved that by using a belt. Now I'll show you what happens. What I can do here is I'll let it run all the way to the end, and I'll leave the motor turned on. And right there it stopped, but it allows the motor to keep on turning without any damage being done to the gears. The only risk that you would have is running it all the way up to the chuck, and of course you can run your table right into the chuck and it's going to do damage before you manage to get it stopped. So I guess the proper thing to do would be to put a work stop on here, or put some kind of limit switch that's going to shut off your motor. Okay, now I'm just going to do a quick sample cut with this. This is just a piece of aluminum. It's an old press roller, so it is knurled, but I'm going to take the knurling off and then cut into it just a little bit to show you how the power feed works. We'll see here, it starts taking material off right away. I'm cutting about 1/1000th of an inch. On the next pass, after I get the knurling off, I'll start making more aggressive cuts with it. And that's pretty good. Okay, on this next pass, I'm going to do about a 3/1000th cut into the aluminum. And it could definitely do it without lubrication, but to keep my tooling sharp, I'm going to put a little lubrication on there. And I'm going to go in about 3/1000th of an inch. And we'll make another swipe. Turn the motor on. Okay, you can see we're not quite through the knurling, and this is why we're getting such small chips here. Usually, you'll see in a minute, you'll get a more, again, I don't know the terminology, but a more aggressive chip, longer strands. So we'll do another 3/1000ths. You can see now we're through the knurling and into the solid aluminum. The power feed really comes in handy when you're turning large pieces, especially like this. You're not constantly cranking on the handle. Yeah, I know you're there. One of the more important things a power feed does for you is gives you a nice, even, smooth cut. I've noticed when I'm feeding by hand, it's really hard to get a good, smooth finish on a continuous piece of metal like this. That allows you to get a nice, I mean, almost mirror finish. And I'll demonstrate that right now. And you can see there, running at the higher speeds, you did see some smoke coming off it, which means the chips were getting quite hot. I should have really used lubrication on that pass, but I didn't for the sake of demonstration. But it gives you a very nice finish on a piece of metal with a power feed, because it's a consistent draw from one side to the other. Here's something that I made out of a piece of scrap aluminum. I know it's not recommended that you make a fly cutter out of aluminum, but what I do is I actually chuck this big part, the big body part of this, into a chuck, into a 3-draw chuck, and that way it sits tight. And I use a draw bolt here that I made out of scrap pieces of metal. I take the draw bolt and put it through the head, which draws it tight, which keeps it very secure. Again, it's probably not recommended to make a fly cutter out of aluminum, but I'm learning. Therefore, it's a nice, easy metal to work with, and it's been very effective so far. I try not to run it at high speeds, just simply because I don't need the tool flying out and hitting me. And I believe that safety needs to come first with something like this, of course. So, you know, take it with a grain of salt. This is just what I ended up doing, and it's working very well for me.